Welcome to day 3 of chapter 18 notes. Today we're going to be discussing reaction mechanisms. Now, reaction mechanisms deal with a complete sequence of elementary steps that make up something called an overall reaction. The overall reaction is a reaction that you guys are used to seeing. That's what I always give you, is the overall reaction. But there's all these little steps, like here, here, and here, that are called elementary steps. Those are their individual steps that make up the overall reaction. Now, to get to the overall reaction, what we need to do is cancel out the substances that are on opposite sides of the reaction. So what I mean by that is notice that N2O2 is a product in one step and a reactant in another step. It's going to cancel each other out. So it's not included in our overall reaction. Another substance, N2O, dinitrogen monoxide there, also starts as a product and ends as a reactant. It will cancel each other out. The substances that we have left over are what make up the overall reaction. So we have 2 nitrogen monoxides, 2 hydrogen molecules. Since those are on the same side, they don't cancel each other out. We just add them up. We have 1 nitrogen gas on the product side and 2 water molecules. So that would be our overall reaction. Overall reactions should always be balanced. So that's a good way to check yourself to make sure it's still a balanced equation. Now, in looking at a reaction mechanism, you're always going to be able to identify what the rate determining step is from your elementary steps, because your elementary steps will always tell you if they're slow or fast. Now, the rate determining step is going to be the slowest elementary step. So what is the rate determining step for the above reaction mechanism? Well, the slow one there is step 2. So step 2 would be our rate determining step. Now here we see a progress of a reaction graph, but it looks a little different than the ones we saw before. Before we just saw ones with a single peak. This one has 3 peaks because we have 3 steps in our reaction mechanism. Here you notice we have 1, 2, 3 total steps. So we have 3 peaks. Now our second step was our reaction, our rate determining step, because that was our slow step. Here, step 2, you can see, has the tallest peak. And because it has the tallest peak, that also makes it the slowest step. So why is this the slowest step? Because it has the highest activation energy. It has the highest wall to overcome in order for that reaction to occur. So in a graph, you can identify what your slowest step is by the tallest peak. That's the one with the highest activation energy, makes it the slowest step, makes it your rate determining step. Now, on top of each step, we have an activated complex. At the peak of every graph, you will notice those activated complexes. So it's an activated complex, that's an activated complex, and we also have one there. Each valley in the graph represents something called an intermediate. Now, an intermediate in a reaction mechanism is a substance that is produced in one elementary step and consumed in a later step. So what that means is that intermediates start as products and they end as reactants in a reaction mechanism. So here it says, what are the intermediates for the above reaction mechanism? Well, if we go back and look, we notice that N2O2 starts as a product, ends as a reactant, and N2O starts as a product and ends as a reactant. So those are going to be our intermediates in that reaction mechanism. Now, something else that we'll notice in reaction mechanism are catalysts. Now, reaction mechanisms, if they have more than one step, will always have an intermediate, but they don't always have a catalyst. So the reaction mechanism that we looked at above did not have a catalyst to it. A catalyst, we know, works by lowering the activation energy and speeding up the reaction rate. In a reaction mechanism, it's a substance that appears as a reactant in one step and is produced in a later step, but not consumed in the complex reaction. So it's not in the overall reaction. We never notice it. So here we see a reaction that includes intermediates and catalysts. So we're going to look at those right now. Remember, when we're figuring out our overall reaction, we cancel substances that we see on both sides of the reaction. Here we see, iodate, IO minus, as a product and then as a reactant. And we also see iodide, I minus, as a reactant, and it ends as a product there. So if we were to write our overall reaction here, we have two H2O2, two hydrogen peroxide molecules, turning into 2 waters and oxygen gas. So what is the catalyst in this reaction? Well, a catalyst, remember, ladies and gentlemen, starts as a reactant, ends as a product. So the substance in this reaction that starts as a reactant and ends as a product is iodide, I minus, reactant, then product. So that is our catalyst in this reaction. The intermediate starts as a product and it ends as a reactant. So our intermediate in this reaction is the iodate ion, IO minus. That's going to be it for our notes today. The next part of our notes, the class practice there, we're going to do in a mandatory session together to make sure that we're all understanding reaction mechanisms.